Hello all, good morning. This is Dr. S. Subbalakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Probability and Statistics, and in the previous class we have seen the definitions and the types of events related to probability and random variables, the first unit of this course. Now we'll have the formula to find the probability of an event. What is the probability of an event? The probability of an event is given by number of favorable events divided by total number of exhaustive events. As we have discussed in the previous class, we have given the definitions for exhaustive events and the favorable events also. First ones, we are going to find the probability of throwing a number 4, a number odd number, an even number with an ordinary die which is 6-faced. So first question is, you are going to get a number 4. You are going to get a number 4. This is what your question is. So what is our favorable event? Our favorable event is getting 4 is our favorable event when throwing an ordinary die which is 6-faced die. So what is the probability of an event as given in the formula? It is the number of favorable events divided by total number of exhaustive events. So in throwing a die there are only 6 possibilities. In throwing a die where there are only 6 possibilities. What are the possibilities? 1, 2, 3, 4, 5 and 6. What are the exhaustive events here? All the 6 are called exhaustive events. These are the possible outcomes here. Therefore, they are named as exhaustive events. So, what are the total number of exhaustive events? Number of exhaustive events is 6. Now, the given question is, you are going to throw a die once and you are getting 4. What is the possibility of getting a 4? Only once. So, what are the number of favorable events? Only 1. What will be the probability of an event? What will be the probability of the given event? It will be number of favorable events divided by number of exhaustive events. Favorable events is 1 and therefore it is 1 in the numerator, and number of exhaustive events is 6 since it is 6-phase, and therefore in the denominator we have 6. So what is the probability? 1 by 6. Now what is the second question? Second question is, you are going to have the odd numbers list. The odd numbers. What are the odd numbers can be can be got in throwing a die? What will be the odd numbers? 1, 3 and 5. As usually, total number of exhaustive cases is 6. It is represented in all the 6 phases of the die, which is 1, 2, 3, 4 and 5, 6. As given here, total number of exhaustive cases is 6. And the favorable events, you are going to choose the favorable number of favorable events. The favorable events is odd number. Odd number is 1, 3 and 5. Therefore, total number of favorable events is 3. Therefore, the probability of the event is given by number of favorable events divided by total number of exhaustive events. Therefore, it is 3 divided by 6, which can be simplified to 1 by 2. The third question. What will be the third question? Total, you are going to have the even number. You are going to have the even number as the throws results. So number of ways of falling a die with even number is 2, 4 and 6. The number of ways is 3. As said earlier, number of ways is 3 only, and therefore the probability is, on the numerator we will have the favorable event, on the denominator we will have the exhaustive events. Therefore 3 by 6, which is 1 by 2 again. So here is how the problem is done using this particular formula. Probability of an event is equal to number of favorable events divided by total number of exhaustive events. So when throwing the event of getting 4 is 1 by 6, its probability is 1 by 6, and for the event of getting an odd number, its probability is 1 by 2, and the event of getting an even number, its probability is 1 by 2 again. So moving on to the second question, we'll have another different example here. In tossing the coin of a head, the probability of getting a head is given by dash, which means you are going to have probability of getting head while tossing a coin in a single time. So what will be the favorable events? Head and tail. In head and tail, we are going to have only head as the result. So it will be the option number of times can occur as 1. And the exhaustive events is only 2, because head and tail is the only 2 possible outcomes in tossing a coin. Therefore, the answer is 1 by 2. Therefore, the probability of the event of getting a head alone while tossing a coin is given by 1 by 2. In a similar way, while throwing a die, the probability of getting 2 is given by in throwing a die means you are having the exhaustive events to be number of exhaustive events is 6. Therefore, the probability of getting 2 is 1 by 6 again. This is how we perform a probability and statistics. So as said here, the number of favorable events is 1, getting 2, and number of exhaustive events is 6. Therefore, it is 6 here. 1 by 6 is the probability of getting 2. Moving on to the next question, it is the probability of throwing number 7 with 2 dice. Probability of throwing number 7 with the 2 dice when added up. We are going to add the given two ordered pairs, and therefore we will be having this number 7. What are the total number of possible ways of throwing 2 dice on simultaneous throw? We will have 6 into 6 possibilities, which is 36. 6 into 6 possibilities, which is 36 here. Therefore, and the sample space will go like with 36 elements. The sample space will have 36 elements. So 36 elements on the hand will have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5 and 1, 6. In a similar way, up to we'll have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6 6 as the ordered pairs here. So this is what our sample space is. In the sample space, we have 36 elements. So how many number of ways of getting 7 are here? How many number of ways of getting 7 are here? Only 6 ways, since while adding 1 and 6 here, you will get 7, 2 and 5, you will get 7, 3 and 4, you will get 7, 4 and 3, you will get 7, 5 and 2, you will get 7, and 6 and 1, you will get 7. Only these are the possibilities here. Therefore, the number of ways of getting 7 is 1, 6, 2, 5, 3, 4, 4, 3, 5, 2 and 6, 1. Probability of getting 7 is number of favorable events. How many favorable events are there? Only 6. What is the number of total exhaustive events? Which is 36. Therefore, the probability of getting an 7 when added up when throwing 2 dice simultaneously is 1 by 6. This is how we perform or do a problem on probability with the formula learned. We'll have some more problems on the next class. Thank you.